Motion, uniform circular motion. First, we see the definition of uniform circular motion. So basically, when an object moves in a circular path with a uniform speed, then its motion is said to be uniform circular motion. Now, obviously in uniform circular motion, object will be moving along a circular path only, and in this type of motion, the speed of object remains constant. That means it is always moving with a fixed or constant speed. But since it is moving along a circular path, so its direction of motion keeps changing. So direction of motion changes at every point, and at every point the direction of motion is given along the tangent to circular path at that point. Also, uh, even though speed is constant, the direction of motion is changing, which results in a change in velocity, and that's why because velocity of object is changing at every point, it is an accelerated motion. So speed remains constant, but velocity changes due to change in direction of motion of the object. So if we want to find out the direction of motion along the circular path at any point P, then it will be given along the tangent to the circle at that point. So we just draw a tangent to the circular path at given point at which we want to find the direction of motion. This will give us the direction of motion at point P. Similarly, at some other point Q, we just have to draw the tangent to the circle at point Q. This tangent gives us the direction of motion of object at point Q in the circular path. Similarly, at some other point R, again we draw a tangent to point R. We get the direction of motion of object at given point R when it is moving this circular path. And similarly, at point S also, we can easily find the direction of motion by drawing the tangent to the circle at point S. That's why we say that the direction of motion is along tangent to the circular path at any point. Now, suppose we consider the motion of an athlete on a circular track. So here our athlete moves in a circular track. Then it is also an example of uniform circular motion. And when moving in the circular track, even though speed is constant, the direction is changing, just like I explained here. So the motion of athlete moving along a circular track is an example of uniform circular motion. And if suppose the athlete takes a time of t seconds to move around the circular track or circular path of radius r, then the speed of the athlete is given by 2 pi r upon t. So the speed v is equal to 2 pi r upon t. Why? Because speed is always given by distance upon time, right? So here the distance covered is equal to circumference of the circular path, that is 2 pi r, and time taken is t. So distance, that is 2 pi r upon time t. This gives us the speed. So this is the constant speed v is equal to 2 pi r upon t with which the object or the person is in uniform circular motion, but their direction of motion always keeps changing. Some other examples of uniform circular motion are motion of the moon and the earth in their circular orbits, motion of a satellite when it is moving in a circular orbit around the earth or other planets, motion of a cyclist moving on a circular track just like an athlete as we have seen earlier. Thank you. Like, share and subscribe to the practical side for more interesting and informative videos.